What I have here is a new Toyota wheel speed sensor. These are a newer style for a lot of things that are past 2007. They go to like 2014. The old type sensors appeared to be, they were like a passive sensor where they would just have two wires just like this, except they didn't have a 12 volt source on one side and then a signal coming out the other side. They actually just swept by the wheel, the magnetic wheel inside your hub, and if you look here you can kind of see it. So you're going to have a ABS signal that comes from this new style that is actually a constant current signal, 7 to 14 milliamp, but it's not actually going to read 7 to 14. It's going to read inside the ECU. If you look at the data, it's going to read 0.7 to 1.4 depending on if it's swept by a negative or a positive magnet as it's passed by here. I've got a little demonstration set up and I'll show you how to connect it and you can test it. Pretty useful for determining whether or not you've got a bad sensor or not, but a lot of people seems like don't really know how they work. I've heard people mention they think it's just a magnet, so they don't know why it's so expensive, but I mean, they're cheap anyway. You can buy cheap ones and test them and verify they work before you put them in. It works out pretty well. These were very cheap. I think these were maybe $8 a piece or something for a pack of 4. Maybe a little bit more than that, but they were pretty cheap. The actual wiring for the truck here, you can see we've got the skid control ECU with actuator. The one sensor that we were messing with was a rear speed sensor on the right hand side. You've got a battery 12 volt, goes into the sensor on one side and then comes back out and runs back into the ECU again. Now what they don't show you is because this voltage here is going to be 12 volts. On this side, you're going to have barely anything because you're actually getting a resistor up inside the ECU. They don't call that out, but in order to get this voltage out, using a 12 volt source and this sensor, you need to have a 100 ohm resistor on it to test it. Just adding a load to it, just the same as with any 4 to 20 milliamp industrial sensor that you put in there. We'll get that set up here and then take a look at it. I've got an oscilloscope set up so we can use that to monitor the signal and we can actually get the same signal to come out that you've got here. So if you want to test a sensor you think is bad, you're not sure if the sensor is bad, or maybe you've got a bad magnetic wheel inside your wheel there. I mean, it's a good way to test. I've got one of these other ones here. You can put a plug on the end of it. The black on this is actually the hot side, so don't pay attention to red and black on this. It's going to be different for the stock harness. This harness itself, the black is hot on this harness. I already have a 100 ohm resistor kind of wrapped around on that side because we're going to need it to test. So we'll put that there. 12 volt power source, Milwaukee M12 battery, works fine. I could use a power supply, but then we'll get some ghost signals inside of it due to, I guess, noise with the power supply. I don't really have a high quality power supply, so it doesn't work to use that. So the big thing is you never really want to hook up 12 volts directly to the sensor. You have to have a load on it. If I were to hook up, you know, my hot side to here and then hook up the battery to here, it's not that it would really kill it, but without the load, it's not going to do anything. It's not going to read properly. The ECU doesn't get a signal from that. Any constant current needs to have, or constant current sensor needs to have a load on the other side. So anytime we do testing and things like that, you have to have a load on it. Otherwise, it's just not going to work. So we can put our battery on that now. Ooh, let's get that. A little bit more meat to grab on there, possibly. So we get that on there. Now let's hook up our scope. And so what we want to see is we want to see this side of the resistor, and we want to see the other side of the resistor. Just grab the other probe right there. And it's hard to see right now, but Let's see if I can remember how to use this thing. Only use it certain times. Oh, you know what? We can just do a measure all. And so we're at 1.5 volts. .500 millivolts per division. So if we put our 0 right here, we're looking at 500, 1000, 1500, or 1.4. And I've got this set up. Look at that. I've got a bunch of magnets all put negative to positive, negative to positive. This will make a really nice signal for us here. So if I take this, and this is going to act just like our magnetic wheel inside the wheel itself that the sensor reads. Negative to positive, negative to positive. And so, just spinning it slowly, you can see, there we go. Frequency is 26 hertz. You go up and up and up. High speed is a closer together signal, 139, 140 hertz it looks like. Moves around a little bit. We know this works because we're getting that signal out. And you don't really need an oscilloscope to check it. What you can use is any other type of meter that you have. So if we were to check this right here, and you always want to check on both sides or either side of the resistor. Oop, clamp that. So meter shows 1.4. We put this in front of it, and we just move it to the next one, and we're at 0.7. The other one, 1.4. And what this does is it allows the car to determine if there's a break in the wire. If you have a break in the wire or the sensor's bad, you're not going to have a constant current out. So you're not going to see 0.7 volts or 1.4 volts. And if it doesn't see either, it knows there's a problem. If you see way too much, it means that it's short the battery, short the power. If you see none, then it's short to ground or open wire. It's just in any kind of current sensing application, you need to know whether or not it's working. And you got to have a low and a high. That's not what you sit at when you read a signal. So you can see the meter doesn't really keep up too well, but you can see the little blip down here as it tries to keep up. That's an older meter. I do have one that's a bit quicker here, an 87, but figured I'd show there's another way you can read it. Not everyone has a current clamp, but in current sources, current sensors, you can read, if you clamp onto it, same as you would an amp clamp. This is an amp clamp, but it's a milliamp clamp. So it's a very precise clamp meant for reading these specific types of signals and controls applications. We can put that there, clamp any of the wires, and now you can see we have 7 milliamp and we have 14 milliamp. And it coincides with the voltage because we're using a 100 ohm resistor. So it's pretty obvious that that's what they're using to get that in there. Did a couple tests with some different size resistors, and 100 ohm makes plenty of sense. Even if you're at 14 volts, 15 volts on the battery, it doesn't change. Constant current doesn't change with a higher voltage. There is a cutoff point when you get low and a cutoff point when you get too high, but within range, constant current stays very constant. That's why they're used in precision control applications. So not everyone has one of those, but if you had one, you could clamp on your sensor to check underneath the car. You could clamp on at any place at near the ECU, whatever wire goes back into the ECU. If you were to clamp anywhere, any of these wires, if you had that meter, any of these wires here, you could see that milliamp signal because it's a current running through the whole thing. Without that, in order to actually test a sensor in place that you're not getting a signal back from, the best thing you could do would be to take and put a harness on it, supply 12 volts to it, so 12 volts on one side, and then take the other side, the open wire, the flying lead, and put a resistor on it and tie that to ground. Just ground it on the frame anywhere, and you can check the voltage while you're doing that, and you should see either 0.7 volts or 1.4 volts. And if you don't see that, you know the sensor is bad. But yeah, that's pretty much it. There's not a whole lot to it, but I did notice there was not a lot of information out there on how to test them. A lot of people not really understanding how they're supposed to work, kind of attributing the new sensors to what the old ones did. And I'm sure there's been a few people who have just kind of hooked a meter up to it thinking they're going to see something and then don't see any appreciable signal. And that's because there's nothing to read. You know, you can't read to ground and then read a voltage on the side that doesn't have a load on it, especially if it's disconnected. So hope that helps.